Mhm. Okay, so in the first question, what we're asked to do is we got to, given the Venn diagram, given the sets A, B, and C, we got to write down the cardinal number. Now, the cardinal number means all the numbers added together. So we're going to get here is going to be 3 plus 2 plus 5 plus 7 plus 6 plus 4 plus 3. Now, remember the thing is that you only have 7 zones. In 3 Venn diagrams, there's 7 zones. So only make sure you add up 7 numbers together. Okay, and this will ensure that you get the correct answer. Okay, so the answer for this is 30 when you put all that into your calculator. Now the next question says the cardinal number of A union B less C. Now less C means that C isn't included. So if you were to put a circle around A union B, so everything in A union B that's not in C. So this is A union B, but you see that there's an overlap with C as well. So we're going to put overlap around C. And as you can see, the only 3 numbers that aren't in C that are in A union B are 3, 2, and 6. Add the 3, the 2, and the 6 together, and what you should get there is 11. The next question is B intersection C. So when you get B intersection C, what you need to do is you need to find the middle of B intersection C, but this answer cannot be in A. So what we can do is we can write a circle around A, a green circle here, and then we put a red circle around B intersection C. Now it's not allowed to be in the green and the red area, it has to be in the red area only, so we know this is going to be 4. Okay, so the answer here will be 4. Now the next thing we need is the cardinal number of A union B union C. That's all of them added to That's all them added together. Now, as it turns out, I made a mistake on the first one because it's only meant to be A union B. So just always read the questions carefully before you do it. Okay, so what we're going to get when we add A union B together. So when you add A union B together, you're only going to be adding 3 plus 2 plus 5 plus 7 plus 6 plus 4. And what that was is 5 plus 12 plus 10. It's basically 27. Now, A union B union C is 30 because it's going to be the 27 from A union B plus 3, and that's going to give you 30. Okay. Next one. In the given Venn the given Venn diagram, the number in brackets represents the number of elements in that region. Okay. If P union Q is 22, and the cardinal number of Q is 3 times the cardinal number of P, find the values of x and y. So the first equation is going to be 4 plus x plus y equals 22. And that's using the first piece of information. The second piece of information is Q. Now Q is x plus y. Okay, so Q is x plus y, and it is equal to the 3 times the cardinal number of P. Okay, and P is going to be 3 times x plus 4. Okay, now what we can do here is we can move the 4 over the other side on the first equation, so we get x plus y equals 22 minus 4, x plus y equals 18. Now what we know about the following is that this x plus y here, this also must be equal to 18. So 18 is equal to 3 multiplied by x, which is 3x, 3 multiplied by 4, which is 12. Therefore, when we move the 12 over the other side, 3x equals 18 minus 12, 3x equals 6. And this means bring the 3 has been multiplied on one side, which makes it divide on the other side. So 6 divided by 3, and that means x equals 2. Now that we know that x equals 2, we know that 2 plus y must equal 18, because x is 2. This means y must be 16. Okay, so therefore y is 16 and x is 2. Okay, and that solves that question there. Next one, 3c. The cardinal number of x is 30, the cardinal number of y is 18. Now, everything that's outside of x union y is 8. So 8 is outside here. What is the greatest possible value of u? Okay, now, the greatest possible value of u. Here we go. Okay, Now in this question, what you have to remember is, just imagine that there's no intersection, and this is 13 and 18, okay? Now 30 and 18 plus 8, so 30 plus 18 plus 8 gives you 56, okay? Now, if you were to put in an intersection of any number, so for the purpose of this question, we're going to say an intersection of 2, just a small intersection. What that will do is it will turn the 30 into a 28, okay? And it will turn the 18 into a 16, okay? And now if we were to add them all up together, we get 28 plus 2 is 30. 30 plus 16 is 46, and 46 plus 8 is 54. So, okay, so what we can see the effect is the intersection lowers down the total U value because the middle is being taken away from the cardinal numbers of the individual sets. So we can see this example illustrates this. So the next thing we're going to do, so if an intersection of 2 makes a big difference, why don't we put all of y? Now y is the smaller set, so why don't we put all of y in the middle, and this will leave x with 12. So 12 plus 18 is 30. 30 plus 8 is 38, and this is the least value of u. So if you can make the intersection as large as possible, it can be only as large as the cardinal number of the lower set, or of the set that is smaller, which is going to be 18. Now the next question says that u is equal to 44. Find x intersection y. If the cardinal number is 44 of the full set, we're going to call what we're looking for, we'll call it x, okay? So the middle is x, so we have to figure out what x is. If the intersection of x and y is x, then it's going to be 30. This number is going to be 30 minus x, and this number here is going to be 18 minus x. So what we can get here is 30 minus x plus x. So we're going to add all three numbers together, and we add all three numbers together, we should get the total value of 44. Okay, so this is all going to equal 44. So what we're going to get next is 30 plus 18 is 48. 48 minus 2x plus x is minus x, and this equals 44. This must mean x equals 4. Okay, next question. Investigate if A intersection B union C is the same as A intersection B union A intersection C. So we got to find this out first. Now the brackets means that B union C has to be first, okay? So we're going to write down what we get for B union C. And what we get for B union C is that, what do B and C have together? They have 3, 4, 5, 6, 8, and 10. Now we have to figure out, what does this have in common with A? Okay, so we have to figure out what B union C has in common with A. So let's find out. So this is going to be A intersection B union C. Let's figure out what they have in common. They haven't got 1 in common. They haven't got 2 in common. They have 3 in common. They haven't got 4 in common. They haven't got 5 in common. They've got 6 in common. And they've got 8 and 10 in common. Okay? So that's A intersection B union C. Now, the next thing we're looking to do is we're looking for A intersection B union A intersection C. So the first thing we need to do is write down A intersection B. Now A intersection B is going to be, what do they have in common? Okay, so let's see what they have in common. So A intersection B is going to be, what do they have in common? So they have the number 3 in common. They have the number 6 in common. That's it. Now we're going to get B intersections, A intersection C. So A intersection C is the following. We're going to see what they both have in common. So A intersection C. So they have 3 in common. They have 8 in common. And they have 10 in common. Now what we're asked to do next is we're asked to get A intersection B union A intersection C. So this is the union of both of these sets. Union A intersection C. And what we get here is 3, 6, 8, and 10. Okay. Now, the property we're what property does this set of investigations prove or disprove? So if you look at this, okay, it's A intersection B is outside the bracket. So what we actually did was we split up the brackets and we said A intersection B, we grouped them together. Then we decided to group A intersection C together. And then we decided to put the union in the middle of these two sets. This resembles the distributive property, where we could have 3 multiplied by 4 plus 5. We group 3 and 4 together. We group the 3 and 5 together, and we put the addition, which was in the middle of the brackets, in the same way that the union was in the middle of the brackets, now goes in the middle of the two new brackets formed. This is a classic example of the distributive property of multiplication over addition, but in this case it's the distributive property of intersection over union. It doesn't matter which one you do first. Okay? Next one, 4b. In a survey, 100 people were asked if they had been on a sun holiday or skiing holiday in the previous year. 60 had been on a sun holiday, 15 had been on a skiing holiday, and 30 had been on neither. Okay? So, if 15 had been on neither, the 15 goes outside. If 30 had been on neither, so there's 100 people in the full thing, so there's 100 people in the full scale. I'm going to call the intersection X. Therefore, the people who went on a sun holiday is going to be 60 minus X, and the people who went skiing is going to be 15 minus X. When we add all these together, we must get 100. Okay, so 15 plus 60 minus X plus X plus 15 minus X equals 100. So what we're going to get here is 15 plus 15 is 30, 90. Okay. That worked right. Now there's 30 people on the outside as opposed to 15, okay? Now the way to notice a mistake is, if I would have got 90 minus X equals 100, and I know X has to be a positive number, so I knew I made a mistake that 30 is actually on the outside and not 15, okay? So what's going to happen is we're going to replace this here with 30, and now we're going to add them up together again, and we're going to get us 105 minus X equals 100. This must mean that X equals 5, okay? So X is going to be equal to 5. Okay. The next question, which is going to be 4C. So, sorry, if X equals 5, we can now do this. Change this to 55. This changes to 5. This one changes to 10. And that's 30. Okay, so that's the appropriate numbers. The next question, okay, once again, we're doing a maximum and minimum value. There's 80 people in here. There's 40 and 50. 40 people in A, 50 people in B, and X in the middle and Y on the outside. What's the maximum value of X? Now, if you imagine there was no people on the outside, so 0 people on the outside, okay, if there's 0 people on the outside, this means that A union B must be equal to 80. Everything must be inside, okay? So what we can do is we can say that this is 40 minus X, this is 50 minus X, and when we add all 3 of them together, they must equal 80. So 40 minus X plus 50 minus X equals 80. Now what's going to happen here is we're going to get 90 minus X equals 80. So the value of X is going to be 10. The maximum value, so X can be equal to 10, okay? For the maximum intersection value. Now, the minimum value of X, what we usually try for the minimum value of X is we're going to try, and once again we have to make sure that everything adds up to everything can add up to 80, okay? So the minimum value of X, okay? Now this here actually is this one here I just did is actually the minimum value of X, okay? Because the minimum value of X is A union B together. So you're basically making Y non-existent, okay? Now, if Y gets bigger, we need the intersection to be bigger. Because remember, a larger intersection, so we'll just take this from scratch again, okay? Remember what happens. When X is a larger intersection, when X is extremely large, when X is much larger, it makes A union B, the cardinal number of A union B, go down. Okay? So, in the first question we're asked, what's the maximum value of x? Now, the maximum value of x we can use is 40. Okay? Now, if we use this as 40, what has to happen here is there's got to be 0 people in here, 10 people in here, which means that there's 30 people outside. Okay? So this makes 30 people outside. So the maximum value of x also correlates with the maximum value of y. Okay? Now, for the minimum value of x, for the minimum value of the intersection, what we need to do is we need to set y equal to 0. Set y equal to 0. And as I said earlier, this is going to be 40 minus x. This one here is going to be 50 minus x. And what will happen is we add all three of them together, and they must equal 80, because the number in the set is going to be 80. So 40 plus x plus 50 minus x to go together, and we get 90 minus x. 90 minus x must equal 80. Therefore, x is equal to 10. So the minimum value of x we can have is 10. Now, find the value of x when y equals 4. So next question we're asked when y equals 4. So what we can do here is we can say y here is equal to 4. And then when y equals 4, this is still 40 minus x. This is 50 minus x. Add them all up together and they all have to equal 80. So 40 minus x plus 50 minus x plus 4 equals 80. So what we're going to get here is 96 minus x equals 80. So as you can see, the presence of y being outside, what it does is it higher the intersection value. So the intersection value is going to be 16. Okay, and that's the end of that exercise.